All right, so welcome back to everyone. A very, very warm welcome to all of you, my dear students. Welcome to the NEET Aspirants. So, guys, this is the third day of 75 hard day challenge in physics, and I'm again here for you. So, let us solve few more questions of the physics. So, see, more questions you will be solving, more comfortable you will be in physics, and more likely that you get a good score in the NEET examination. Okay, so basically it is all interrelated. So guys, I am your physics educator, Dr. Umashankar, and these are my brief credentials. So let us come to the point. Let us start solving today's question. Okay, okay. So here we go with the first question. So the students who are watching the video may stop the video and solve this question and can answer in the chat, or you can answer in the comments. See, each of this question you have to solve by yourself before I solve it here. Okay. Okay. So now let's solve it. Okay. So the live students can also answer this question. So it says if E is the charge, V is the potential difference, T is the temperature, then the units of EV by T are the same as that of. So guys, what is E into V? What is E into V? It is basically work done. It is basically work done, right? And this is divided by T. Okay. So work done, we also know it is pressure into volume. So it is basically PV by T. So when we write EV by T, dimensionally it is same as that of PV by T. And PV by T is what? It is the Boltzmann constant. It is what? It is the Boltzmann constant. I hope it is fine to everyone. So the answer to this question is what? The answer to this question is the Boltzmann constant. Okay. Okay. I hope you guys have given the correct answer to it. Now let's move to the next question. So every day, see guys, we are solving the questions here, and I'm very sure that you can excel in your NEET preparation when you solve the question on the daily basis. Now let's solve this question. Very interesting question. Please try it. Please try it. I'm very sure we can do it. Please try the question. So now what is the dimension of mobility? Sir, we don't know what is mobility. So I'll give you just one formula if at all you haven't completed this chapter yet. So for that to help you, I'll give you one formula. So the drift velocity, okay, you are going to see something else. The drift velocity, it is equal to mobility. It is equal to mobility into electric field. Mobility into electric field. Okay, now please try this. I'm very sure we can answer this question. Right, so we are asked about the dimension of mobility. So see, you can get the dimension of any parameter. You can get the dimension of any parameter if you have the formula of it, or if you have the unit for it. Okay, okay. By means of those, I'm sure that you will be able to get the dimension of any quantity. So what is the formula for here? So it is drift velocity is equal to mobility into electric field. Okay. Okay. Now let's talk about. So we know it is velocity. So somewhat when it is velocity, the dimension. So let's write the dimension of drift velocity. Dimension of drift velocity. Okay. So it is velocity. So ultimately it is going to be meter per second. So it is m0 lt minus 1. Okay. Okay. Then we have the electric field. So what is the electric field? What is the electric field? So sir, electric field is force into force by charge, right? It is force upon charge, isn't it? So what is going to be the dimension to it? what is going to be the dimension to it? So see, the dimension of force we must memorize. So it is MLT minus 2. And what is the dimension of charge? So it is I into T, electric current into time. So for current, we can use I. Okay, we can use I, seeing the, okay, so no, we can use A. Okay, seeing the option, we can use A here. So current is A and time is T. So what is the electric field dimension? So this is going to be M L T minus 3 A minus 1. M L T minus 3 A minus 1. So what is going to be the dimension of mobility? So we can put the dimensions here. So it is going to be LT minus 1 upon, so what is the dimension of electrical field? So it is MLT minus 3, MLT minus 3, A minus 1. So what is going to be the option? What is going to be the option? So it is going to be the M minus 1, okay, M minus 1, L, there is no L, okay, and T, so it will become, so it will go to, it will become T square and A. So what is the option? Option is B. Option is what? Option is B. I hope it is fine to everyone. Right? Now let's try this one. Very interesting question. So see, a lot of questions are getting asked from units and measurement. So each of the chapters, see, each of the chapter we must at least do 40-50 questions. Okay, if you want to, if you want to be comfortable in any of the particular chapter, especially in physics, at least 40-50 questions are required from each of the topic. Okay, so please try this one. I am very sure we can do it. No problem at all. Please go for it. The live students can do and respond in the chat. Please try it. I'm very sure we can do it. What is the answer? So sir, this question is from the dimensional homogeneity. Okay, so through the dimensional homogeneity, we learned to relate the, we have learned to relate the, what? Sir, we have learned to relate the various physical quantities involved in any physical phenomena. So it says the velocity of water waves may depend upon their wavelength, density of water, and the acceleration due to gravity. Acceleration due to gravity. Okay. Okay. So here, how can we do? So we understand this, so we can do it. So now I hope you guys have attempted the question. If you haven't attempted, please stop. Please attempt the question first before you see the solution to it. Otherwise, it is not going to be benefited to you. Okay. Okay. So you have to always do the question first before we solve it here. Okay. Then only you come to know whether you are able to recall the concept rightly or not. Okay. Then it is going to have some use. Now it says the velocity of water waves may depend upon on their wavelength. Okay. So we can say that velocity is proportional to L to the power A. L is the wavelength. Density of water, so R to the power B, and the acceleration due to gravity, so G to the power C. Now it means that if I merge all this thing, so we can say that velocity is equal to L to the power A, R to the power B, G to the power C. K is the constant of proportionality. It doesn't have any dimension. Now, if I say, if we know, so we already know it. So what do we know? So we know that the dimension of the left hand side must be equal to the dimension of the right hand side. The dimension of the right hand side. So it will become LT minus 1. Okay, so K has no dimensions. Let it go. Now L, wavelength. So the dimension of the wavelength is L. So it will become to the power A. R is the density. So density is kg per meter cube. That is M L minus 3 to the power b, and g is acceleration due to gravity, that is meter per second square. So meter per second square to the power c. Now from here, can we write b is equal to 0 clearly? B is equal to 0. Okay, because see here on the left hand side, m is equal to 0. Now let's come to the options. Okay, so density. Okay, so see in no option density is mentioned. So you cannot come to the correct conclusion here. So no problem. Now we can write a minus 3b plus c is equal to 1. So how you get that? So basically we have compared the powers of the same bases. So if I see on the power of the base L on left hand side and right hand side and equate them, I'll be getting a minus 3b plus c is equal to 1. And what else? So what is the power to t here? To t is equal to minus 2 of c. Minus 2 of c, and here it is minus 1. Here it is minus 1. So c is going to be 1 by 2. C is going to be 1 by 2. Okay. So C is going to be 1 by 2. Okay, very well. C is going to be 1.2. No problem at all. Now C we have, B we have. So B is 0, C is 1 by 2. So A is minus 1 by 2. A is equal to minus 1 by 2. Isn't it? A is equal to minus 1 by 2. Right? Right? Okay. Is it right? Okay. C is 1 by 2. This is 0. So 1 minus 1 by 2. So it is, sorry, it is plus 1 by 2. My bad. Okay, so when we are putting C is equal to 1 by 2 here, B is 0. So 1 minus 1 by 2 is 1 by 2. So A is 1 by 2, C is 1 by 2. Now if we come back here, so we can write V is proportional to C. B is 0, A is 1 by 2 and C is 1 by 2. So that means L to the power 1 by 2, G to the power 1 by 2. So so it is actually gamma wavelength. So but we have taken it as L, that's okay. No problem, we are knowing the answer. So if I square this both sides, if I square this whole equation, so I'll be getting what? I'll be getting V square is equal to G lambda. So that is your B option. That is your B option, right? Okay. I hope it is fine to everyone. I hope it is fine to everyone. Okay. Okay. So let's try one more. Okay. Let's try this one. I'm very sure we can do it. Please go for it, guys. Please go for it. Please go for it. I'm very sure we can do it. Very, very simple question. Very simple question. So, sir, are they asking this kind of question? Yes, yes, definitely they are asking this kind of question. Please go for it. So the unit of impulse is same as that of what? So what is the impulse first of all? So the impulse we know it is force into delta t, change in time. So force that is Newton, okay, and Newton, and this is time. So Newton into time, right? Newton into time, right? Or if I further reduce this, so it is going to be kg meter per second square. kg meter per second is square into second. So it is going to become kg meter per second. This is the unit of impulse. Now, what is the unit of energy? Sir, it is Newton meter. It is not definitely not this. Sir, it is Newton meter per unit time. So Newton meter per second, right? So I'll write here second. So Newton meter per second. Newton meter per second. So definitely it is also not this. What is this, sir? So momentum is mass into velocity. Okay. So mass into velocity, that is kg meter per second. So it has to be the answer. It has to be the answer. I am sure that you have got this. Okay. Now let's move to the next question. Oh, let's try it. Please try it. Correct. I'm very sure we can do it. So कैसे करेंगे sir? So if Q denote the charge on the plate of the capacitor of capacitance C, then the dimensional formula of Q is square by C. So sir, if you remember, अगर आपको पता हो, so if you know it, so let's do it. So E is equal to Q square by C. So this is the standard formula now. This is the very standard formula. Let's solve it. So E is equal to Q square by 2C. So when E is equal to E is what, sir? E is the energy. So basically when Q is square by 2C is the dimension of energy, Q square by C also will have the dimension of energy. Okay, so what is the dimension of energy? Sir, force multiplied with some length. So force is MLT minus 2. So MLT minus 2 into L. Okay, MLT minus 2 into L. Okay, I hope it is clear to everyone. Okay, okay. Now let's try one more. Let's try one more question. I'm very sure we can do it. Very, very simple question. Very simple question. Let's try this one. Okay, so let's try this one. I'm very sure we can do it. I'm very, very sure we can do it. No problem at all. Please try it. Please try it. I'm very sure we can do it. Please try it. Very simple. So it says, so first try to understand this question. See, again, this is a question of dimensional analysis, previous year question, a good question. See, with each of the question, your concept will be more and more, solidified. So the mass of the liquid flowing per second per unit area, okay, per second per unit area. Please read the language. Per second per unit area of the tube is proportional to pressure difference across the end and average velocity of the liquid. Which of the following relation between m and n? So they are given as the power. So how to do it? Very, very simple. Again, the question from the dimensional homogeneity. Please solve it. Please try. So the mass of the liquid flowing per second per unit area of cross section of the tube is proportional to pressure difference across the end and average velocity of the liquid. Okay, which of the following relation between m and n is correct? So how we can do it? So see how we can do it. So it says the mass of the liquid flowing per unit area of the cross section per second per unit area of the cross section. So mass per unit area per unit time, okay, is, so see, mass of liquid flowing per second per unit area. So definitely mass is divided by area, and the time, okay, of the cross section of the tube is proportional to pressure difference. So pressure difference, so that will be delta P obviously. So dimensionally we can write it P. Okay, doesn't matter. Dimensionally, because the dimension of the pressure and pressure difference are going to be same, and average velocity of the liquid, that is m. Average velocity of the liquid, that is m. Which of the following relation between m and n is correct? Okay. Okay, so here m is the mass. So see, we can do the dimension like this. So it is m, mass m. This is L minus 2 and T minus 1. L minus 2, T minus 1 is equal to, so this is pressure. So this is MLT minus 2 upon L square force upon area to the power n, and then V is LT minus 1 to the power m. LT minus 1 to the power m. So m L minus 2 T minus 1, this is proportional to, so what we can write? So we can write m L minus 1 T minus 2 to the power n, okay, and this is L T minus 1 to the power m, okay. Okay, so see directly, so see, we can make some, we can compare the powers of the same basis as always. Okay, so when we are comparing the power of the same basis, can we say, see, n is equal to 1 straight away, and now see, so minus n plus m is equal to minus 2. Okay, comparing the power of, this n. Okay, so when I do that, so from here n is equal to 1. So if I put n is equal to 1, okay, so if I put n is equal to 1, so can I write here n is equal to 1? So when I write n is equal to 1, m is equal to minus 3. Okay, m is equal to, sorry, minus 1. Okay, so now n is equal to 1, m is minus 1. Now n is equal to 1 and m is minus 1. So that is m is equal to minus of n. M is equal to minus of n. So what is going to be the right option? The right option is going to be the B option. I hope it is clear to everyone. Right? Very interesting question, isn't it? Okay. Okay. Now, okay. So let's move to the next question. Let's see if we have some good question there. Okay. Let's try this one. Let's try this question. Please do it. Please do it. I'm very sure we can do it. Please try it. Let's try this one. So it says turpentine oil. Please try to do it. It says turpentine oil is flowing through a capillary tube of length L and this D. So see, very simple question again of the question of dimensional homogeneity. So we can obviously solve this question. Please go for it. Please go for it. I am very sure we can do. Please try it. Please try it. Please try it. How can we do it? So the very simple question. It says turpentine oil is flowing through a capillary tube of length L and radius R. The pressure difference between the two ends of the tube is P. The viscosity of the oil is given by eta is equal to P R square minus x square upon 4 VL, where V is the velocity of oil at a distance of x. V is the velocity of oil at a distance of x from the axis of the tube. From this relation, the dimensional formula of eta is. So what is the dimensional formula of viscosity? Now see, this is P. So let's right away write the units of it. So pressure is force upon area. What is the dimension of force? Sir, MLT minus 2. And what is the dimension of area? The dimension of area is L square. So it will become M L minus 1 T minus 2. Okay. Then we have R square minus X square. So R is the radius, X square. So what is the dimension to it? So it is going to be L square, because R square, it is something of, dimension of L, dimension of length, and we have the X square, which is again a distance, so the dimension of L. Okay, so it is going to be L square upon 4VL. So what is V? V is velocity. So it is going to be LT minus 1, and this is going to be L. So what is going to be the dimension of viscosity from here? What is going to be the dimension of viscosity here? Okay, so it will become C. L square will be cancelled out. M will be there, L minus 1 will be there, and T minus 1 will be there. 4 has no dimension. So what it will be? Some L minus 1, T minus 1. So it is going to become M L minus 1, T minus 1. I hope it is fine to everyone. So this is going to be the dimension of viscosity. Now let's try one more question. Very interesting question. Okay, let's try this one. Please try it. Please try it. So how many questions we have done till now? Let's see. So 1, 2, 3, 4, 5, 6, 7, and this is the eighth one. Let's try this. I'm very sure we can do it. Please go for it. Let's try it. Let's try it. I'm very sure we can do this. how we could do it. Please go for it. How we can do it. Please try it. So very interesting question. So it says the Richardson equation is given by I is equal to at square e to the power minus b by kt. The dimensional formula of a b square is same as that of. Okay. Now please understand this very interesting question. So it says I is equal to at square e to the power minus b by kt. Now e to the power e to the power minus b by kt. It has to be a number. E to the power something. It has to be a number ultimately. So the dimension of a will be equal to the dimension of I by t square. This is for sure. This is for sure. Okay, sir, how you have writing it? So this is a dimensionless thing. Now this whole thing has to be dimensionless. Okay, it represents a number. So a, the dimension of a will be equal to the dimension of I t square. So I just write a is equal to I t square. It doesn't mean that a becomes equal to I t square. Just we are talking about the dimension. Do remember that. Okay. So the dimension of A will be equal to I by T square. Now, see, B by KT. So this thing has to be a number again, e to the power minus something. So this has to be dimensionless. So it is only possible if this thing has to be dimensionless. So means the dimension of B must be equal to the dimension of KT. Otherwise, how it is possible? Otherwise, it is not possible, right? The dimension of b by, so the e to the power something, so it has to have the dimension, of, it have to have the dimension of this b and kt must have the same dimension. Okay. Okay. Okay, so now what is going to be ab square? So ab square is equal to I by t square. Okay, so this is k capital T. Okay, let's write capital T, otherwise confusion will happen. So I t square and this is b square. So what is b? B is k t square. Okay, so it will become I k square. It will become I k square. Okay, I hope it is fine to everyone. Yes or no? Are we okay with this? Are we okay with it? Yeah, please answer me. Okay, let's try one more question then. Now let's try it. Let's try one more question. Okay. Let's try one more question. Let's try. I'm very sure we can do it. Please go for it. Very simple question again. I'm very sure we can do it. No problem at all. Please go for it. Please go for it. So it says given that y is equal to a sine 2 pi by gamma ct minus x. Okay. Now y and x are measured in meter. Okay, very well. Which of the following statement is true? Which of the following statement is true? Okay. Now please understand. Please, very interesting question. Now see this sign and within sign we have something. So it has to be an angle. Okay. Anyway, it has to be an angle. So whatever written inside the trigonometric function is going to be an angle. Okay, now what is the dimension of an angle? So the dimension of an angle is m0, l0, t0. Angle is a dimensionless entity. Okay, so angle is the supplementary quantity, and supplementary quantities are the only quantities which have units, but they don't have any dimension. So this has to be dimensionless. Now this, the dimension of x is given to be meter. Now what is the dimension of ct? It has to be meter. Okay. So the dimension of this whole thing ct minus x has to be meter. So the dimension of gamma has to be same as that of this x. It has to be meter, right? So now this is the true option, right? This has to be the true option. Okay, now let's move to the next question. I'm very sure we can do it. So let's go for this. Let's try this one. Let's try this one. I'm very sure we can do it. Please go for it. Please go for it. Please observe the question. I'm very, very sure we can do it. Let's try this one. So if L is equal to 2.331 centimeter and B is equal to 2.1 centimeter, then L plus B is equal to, okay. Now these are, these are two significant figures. So what is the concept we have? So the concept is when two significant figures are added, the solution or the addition, the result of the addition must be rounded off to the decimal place, to the same number of decimal places as present in the value with the least decimal place. So if I sum this up, it will become 4.431, right? But this is not the final answer. I have to round this off to two decimal place. So when I need to round this off to two decimal place, obviously it is going to become 4.4 centimeter. This is going to become how much? This is going to become 4.4 centimeter. Okay. So guys, in this session again, we have solved 10 questions of the physics from the first chapter, units and measurement. And as I said, see, in each of the chapter, if we are able to do some 40-50 questions, then that chapter is going to be a good chapter for you. Okay, so we'll try to come up with more and more questions every day, and we can, quickly revive the concept of the subject while doing the questions. Okay, and lately I'll be coming up with the mixed question. I'll mix the question between the chapters and we'll come up with that for you. Okay, so guys, this was the third day of 75-day hard challenge. Okay, so in this, we every day we are doing some questions of the physics. Okay, and biology Hassel is doing. Okay, so definitely I hope you are going to enjoy these sessions, and these sessions are going to be very, very helpful for you guys. So guys, please don't forget to subscribe the channel, like the video and share it to your friends so that they can also join the session and can solve the question and get maximum benefit. Okay, so that will be all in this session. Thank you very much. Have a good day, and we'll see you in the fourth day of this 75 hard day challenge. So with this, thank you very much. Don't forget to subscribe the channel.